Hi, I'm Daniel Pohl, research scientist at Intel Labs. Today we're going to show you a very cool demo, Wolfenstein Ray Traced, and it's running on this small laptop in real time. So what you see here is the Wolfenstein game content rendered in a new renderer that does ray tracing for us. It's running on 4 servers that are all equipped with Intel's Knights Ferry card, which is a highly parallel many-core architecture. And we use these servers to calculate the image, and then we stream it one by one to this thin client, like a small laptop for example, to get the game to be rendered in real time. Also, we changed some parts of the original map. For example, we replaced the regular car that comes with the game with a more detailed car. We also added a special shader to it to make it with more reflecting special effects, looking more like a car with lots of reflections, which you can see here. You see like these monsters, for example, getting reflected in this car through the shading system. Or we can also do a close-up on it, where we see clearly, like on this part, there are monsters walking by. On this part, you can see the reflection. Here you see another reflection. If we look close on the top, you also see another reflection, and so on. So these effects are very good doable with ray tracing, which we are demonstrating today. Ray tracing itself is a rendering algorithm. It's used to create images out of a 3-dimensional scene. There are a variety of methods you can use, like ray tracing or rasterization is the current one that's used in games. There's other one like voxel rendering, point rendering, etc. But today we show ray tracing, and you can see here, given our setup with the servers and this thin client, we get a frame rate of over 80 frames per second. The resolution is 1280 by 720. Another thing we replaced in this map is this chandelier. We downloaded a very high-res model which has 1 million triangles to add all these detail in here. So 1 million triangles, that is 3 times more triangles than all the rest of the map has with all these walls, ceilings, objects, etc. To show you how it looks, if you only look at the triangle count, we have here visualization where you can clearly see where triangles start and end. You see, the general geometry is rather coarse, but here you have lots of tiny details in this chandelier. To make it look very cool, we changed the shaders on it. We have glass shaders, like all these little pearls here are made out of glass. They're reflecting, refracting. These plates here do the same. And let's have a closer look at these plates, how they look if you zoom into it. As you look close here on this plate of the chandelier, you will see that all the objects in the background are getting refracted. For ray tracing, we are using the correct refraction index for glass, as you find in every physics book, and these calculations are also done like it would happen in nature. We have a real refraction happening, and we get these very cool distortions that you wouldn't get in a regular game. Also, what we are showing today is a gaming-like particle system in this real-time ray tracer. You can see here fire and smoke that gets simulated over a bunch of particles. And let me show you how that works. We can switch over to the triangle view, and suddenly you notice that all your smoke and fire is in reality a bunch of quartz, which have a texture on them and they're partially transparent. In a ray tracer, this is an especially difficult problem because, as you can see here, your fire and smoke consists of multiple of these layers, and a ray has to shoot from the first layer to the second, to the third, etc. So there are a lot of intersections to be calculated. Another very cool special effect we added, which isn't like this in any other game, is the sort of surveillance station. You can see here 12 different screens, and they are showing 12 distinct locations of the level at the same time. They're all getting updated in real time. And if you take a look at the performance, we are still running here at pretty smooth 44 frames per second. So for gaming, this means you could imagine you have a deathmatch level where you put in such a surveillance station, and players could go there, could get a good overview of the map, could detect where are my enemies, and then get a strategic advantage by having this surveillance station. Also, as a little extra gimmick, we have here one screen of the surveillance station that's looking back at the surveillance station itself, so even these recursions and recursions work. Also, if you want even more detail, we can even zoom into this and see again the next screen with recursions and so on. Also, if you play a deathmatch game, wouldn't it be nice to know what's happening behind you? So in ray tracing we can do this sort of thing. We have here a sniper rifle with a reflecting scope, so here at this point we can see what's happening behind the player. So in this case we can see approaching enemies, and through this knowledge we can turn around and deal with it and get a tactical advantage. So that's our demo. And well, you've seen with the cloud computing, using 4 servers with Ferry in it, we can even enable on such a thin client very cool looking graphics, which wouldn't be possible otherwise. And with ray tracing, we've also shown you a lot of cool special effects that are not in today's games, like reflections, refractions. We have tactical gaming advantage with the sniper rifle, we have the surveillance station. So lots of cool stuff I'm looking forward to see in future games.